Okay, so this video is going to show the final review for the multiple choice section. And there's actually going to be two videos for this because there's a lot of multiple choice questions. So this is just the first of two videos. So let me go ahead and zoom in a little bit so we can see well. So we're starting by solving equations by factoring. These first four questions are all factoring. So the first one, I'm going to go ahead and start by finding my a times c and my b. As a reminder, your a, b, and c are just these numbers. This is a, b, and c. And since there's no number in front of the x squared, it's just 1x squared. So 1 times 8 is 8, and my b is 6. And then I need two numbers that multiply to 8 and add to 6, which would be 4 and 2. Because a is equal to 1, I can just immediately factor this to x plus 4 times x plus 2. Now here's the tricky thing is some people will think that 4 and 2 are their answers, and those are not your answers. So if you set each of these equal to 0 and solve for x, those will be your answers. So I'm going to minus 4 from both sides, so x equals negative 4, and minus 2 from both sides, and x equals negative 2. So negative 4 and negative 2 are question D. On number 2, it's the exact same thing. So my a times c is 5, my b is 6. I need two numbers that multiply to 5 and add to 6. So 5 and 1 multiply to 5 and add to 6. So this factors to x plus 5 times x plus 1. And if I set each of those equal to 0, I'll get negative 5 and negative 1, which is C. Number 3 is actually one of the easier ways of factoring, but is also one of the things that throws people off the most because they start trying to find their a, c, and b, when the first step you should actually always look to do is see if there's a greatest common factor you can pull out. And since these both have an x, I can factor out an x, and then I'm left with x plus 5. And once I'm there, I don't even need to go any further to find any a, c's, or b's. I can just set each of those factors equal to 0. And on this one, I've got a minus 5 from both sides. So x equals 0 and negative 5. Again, be careful because 5 and 0 is an option. So don't just look at this and think, oh, 5, I'll circle 5. Make sure you actually set it up and solve so that you don't trick yourself out of some easy points. So number 4, we're going to start it the same way we did 1 and 2 because I don't see a greatest common factor in 6, 11, and 5. So 6 times 5 is 30. And b is 11. So I need two numbers that multiply to 30 and add to 11, which in this case is 6 and 5. So unfortunately, unlike 1 and 2, I can't just say x plus 6, x plus 5 and be done because this a is not equal to 1. That only works if a is equal to 1. So instead, I'm going to take these two numbers and I'm going to plug them into my equation instead of the 11. So I have 6x squared, and then instead of plus 11x, I'm going to do plus 6x plus 5x, which really is the same thing because 6x plus 5x is 11x, but splitting it up using these numbers is going to make it much easier to factor. So once I've set it up like that, I'm going to go ahead and group both sides. So over here, I can factor out a 6 and an x, and I'm left with x plus 1. And over here, I can factor out a 5, and I'm left with x plus 1. So because my parentheses match, I can pull out that x plus 1, so these are gone, and then I'm left with 6x plus 5. So now I have this factored, and all that I have left to do is set each of those factors equal to 0 and solve. So I have x plus 1 equals 0, so I'm going to minus 1 from both sides, so x equals negative 1. And then I have 6x plus 5 equals 0, so I'm going to minus 5 from both sides. So 6x equals negative 5. Divide by 6 on both sides, and x equals negative 5 over 6. So I have a negative 5 over 6 and a negative 1. So that's a brief review of factoring, and there will be one like each of those on your final exam. The next section is asking us to write a rule to describe each transformation. So I can tell based on the apostrophes that this is going from here to here. It starts with just D, E, F, and then goes to D prime, E prime, F prime. So if I look at this, the size of each triangle looks the same, so it can't be a dilation. And then it doesn't look like it's moved up or down at all, so it can't have gone 7 units up. So the only option left is 3 units right. And if I count this, 1, 2, 3, 1, 2, 3, 1, 2, 3. So this translated 3 units to the right. Number 6, I have this shape that ends up over here. So again, it looks like the same size, so I'm going to say no to the dilation. This didn't move up or down at all, so it can't be up. So it's got to be a rotation of either 180 degrees or 270 degrees. I know rotations of 180 degrees just change my points to the opposite. So like this point here, L, that's at -4, 2, if it rotated at 180 degrees, point L should be at 4, -2. So if I look here, oops, excuse me, those are definitely 5s. So -5, 2, 5, -2. So 1, 2, 3, 4, 5, down -2. So this rotated 180 degrees, which you can also kind of just see by looking at it. If you were to take this point and move it 180 degrees in a circle, it would end up right there. Numbers 7 and 8 are still asking for rules. So if I look at these, reflection across y equals -x. I don't think that's what it is. And then it may be rotated, but not 90 degrees. Reflection across the y-axis. So if I took this point and reflected it across the y-axis, instead of being 3 this way, it would be 3 that way, and it is. And this one's 5 this way, then becomes 5 that way, 2 this way, 2 that way. So this one reflects over the y-axis. Number 8 is the first one where I see a size difference, which immediately screams at me dilation. And the only dilation option is C, dilated by 1.5. So if I took this point 3 and multiplied 3 by 1.5, that would be 4.5. And this point does go to 4.5. So I can double check to make sure that that dilation's correct. Number 9. It gives me a center and a radius and then wants me to write the equation in standard form. So I'm just going to ignore the options and do this problem because I know how to do it. So when I write it in standard form, I have x minus a -11, which would be x plus 11 squared, plus y minus whatever this y value is, so y minus 3 squared, is equal to the radius squared, which is 4 squared or 16. So if I look through my options, that is option A. Number 10, I'll go ahead and just think through it. So this would be like x plus 0 squared or x minus 0 squared. Well, x plus 0 is just x, so that's going to be just x squared, which there's really only one option with that, so I'm just going to double check to make sure that's right. So y minus a -3 would be y plus 3 squared equals the radius squared, or 3 squared, which is 9. So the answer to 10 is C. Numbers 11 and 12, I think I'm going to just show you one and then have you try another. So I'll show you number 11, and I'm going to go ahead and do it in this blank space right here. So I need to start by grouping my x's and y's together. So I have x squared and a 22x, and then I leave a space, plus y squared minus 18y, and leave a space. And then this doesn't have an x or a y, so I'm just going to subtract it to the other side. So this is equal to -166. So to fill in this blank, I'm going to take my b term, which is 22, and 22 divided by 2 is 11, and then I'm going to square that. So 11 squared is 121. But if I add 121 to this side, I have to add it to the other side. Then the same idea here, -18 divided by 2 is -9. -9 squared is +81. So I have to add 81 over here as well. So then I can now factor this, because two numbers that multiply to 121 and add to 22.
Okay, so there were just so many files I got really
Sorry for that little glitch in the video, but I'll go ahead and keep going. So two numbers that multiply to 121 and add to 22 are 11 and 11. And if you have a hard time figuring that out, it actually, when you're completing the square, which is what we're doing, whatever this b term divides by ends up being this number. So 22 divided by 2 is 11, which is why we did 11 squared to get our 121. So it's always going to end up being that number. So like here, negative 18 divided by 2 is negative 9, so that would be y minus 9 squared, and I can check it because negative 9 plus negative 9 is negative 18, negative 9 times negative 9 is 81. So that's all equal to negative 166 plus 121 plus 81. So that's equal to 36. So this answer looks like option A. So I'm going to go ahead and let you try that same process on number 12. And it was kind of a lot really fast, so if you need to rewind it and watch it again, that's totally fine. Number 13 is asking for the center and radius. And the biggest thing to be careful of on this is to make sure you know your signs. So your center ends up being a positive 15 and a negative 16. So that's C or D. And then this often confuses people because this is equal to your radius squared. So I could rewrite 9 as 3 squared. So my radius is 3. But oftentimes people will get confused and just square the 9 and say their radius is 81. So be careful of that. 14 and 15 are asking me to convert each degree measure into radians and each radian measure into degrees. So I have pi over 6 for number 14. And to put things in degrees, degrees is equal to 180, is equal to radians times 180 over pi. So my radians is pi over 6, so I'm going to do pi over 6 times 180 over pi. And you can do this by hand or enter it into a calculator, but when you multiply that through, it comes out to 30. So pi 6 is 30 degrees. Versus when we're going into radians, radians is equal to degrees times pi over 180. So it's backwards of this. So I have 45 times pi over 180 and 45 times pi over 180. I will actually, when you take your final, give you the decimal version on the board. So if you do it in a calculator, that is totally fine. So if you put it in a calculator, you end up with about 0.78 radians. If you don't do it in a calculator, it comes out to pi over 4. And if you had these options, you could always check that, and in your calculator just do 3.14 divided by 4, and it comes out to be 0.78. So you can kind of go back and forth with those. This next page, and I think this is the last page we're going to do for this video, is just like what we've been doing in our very last unit. So the tangent, this is our SOHCAHTOA, so I'm going to go through these very quickly. So tangent is opposite over adjacent, so opposite over adjacent is 4 over 3. Cosine is adjacent over hypotenuse, so adjacent over hypotenuse is 21 over 7 square roots of 10. And then 21 divided by 7 is 3 over the square root of 10, which actually is not given as an option, but I will make sure that that does not happen on your final. And then sine is opposite over hypotenuse, which is 8 over 10, which simplifies to 4 over 5, so that is A. And then 19, the sine of theta is opposite, which is 7 over hypotenuse, which is 25, or D. And the reason this one turns out weird is because oftentimes people don't like radicals in the denominator. So if you were to solve this, you would actually multiply by the square root of 10 over the square root of 10. So you'd have 3 square roots of 10, and then the square root of 10 times the square root of 10 is just 10. So the correct option is here. I just didn't teach you how to simplify it that way, so on your final you will not have to simplify it in that way. And then I'm going to go ahead and start the next video with 20 through 23.